Alright, welcome to Unit 3, Trigonomic Functions. This video is over graphs of sines and cosines, Part 4. Yeah, we've made it to the very end. This is actually, again, it's not an overly difficult topic, just kind of long. A lot of little details. So we've talked about how to graph the basic parent functions of sine and cosine. We've talked about all the different features of them. We've looked at some examples. We identified the big 5 points. And then we talked, of course, about the amplitude, the period length, and the midline. Those are really the 3 key features that not only make the graph what it is, but it makes the function what it is. So what we're going to kind of look at now is, I really want to focus once again on those big 5 points. Make sure you truly understand those, because I want to make sure you guys see how those points can be transformed. So we're going to talk about that. And I also really want to talk about, actually how to build these functions through what we see. All right, so in the previous video we mentioned, a midline shift is basically a vertical slide, vertical up or vertical down slide. And when you change your midline, what you're doing is you're changing the entire graph in terms of vertically, up or down. When you change your period length, you're stretching it or shrinking it horizontally. You're either taking that one period length of sine and making it faster or longer. Same with cosine. And then an amplitude is a vertical stretch or a vertical shrink. So imagine us taking the min and the max points and really kind of stretching them up and down. But we could also make a graph translate left or right. So let's talk about this very briefly. So this is the only other thing that we haven't talked about. So let's look back at those functions here. And again, it's the same basic idea whether you're working with sine or cosine, but A is for the amplitude, B is the period length. Now remember that the period length is not B, it's 2 pi divided by B. D is that midline, and then now we're introducing C. C is adding or subtracting a constant inside of the function, and if you remember from when we did our transformation unit, this is a horizontal slide left or right. So if it's plus C, that actually goes to the left. If it's minus C, that actually goes to the right. Hopefully you guys remember that. But I want to make sure I mention 2 issues here. Often these translations are hard to see because the graphs go forever and ever in both directions. So for example, a sine curve just keeps doing this forever and ever and ever and ever and ever. It never stops, both directions, by the way. So if you take that curve and you just slide it one way or slide it the other way, you're sliding it to where the curve already existed. So again, they're just kind of hard to see. With sliding, also a sine curve could easily become a cosine curve. So let's talk about that real quick, because this is important to understand. So remember, the key characteristic of a sine is that it starts on its midline. So if its midline is the x-axis, it starts on that midline, goes to the max, midline, min, back to the midline. Sorry, that's kind of poorly drawn. But just think about this. If I took a sine curve and I slid it left, just slid it left a little bit, imagine now it looks like this, right? Where I took that initial starting point and it slid over to here, and I took this max and it slid over to here, and I took this midpoint here and it slid. So again, the whole thing slid over, right? Now, what do you notice about this is that it actually kind of looks like a cosine curve, because cosine curves start up on the y-axis and they come down, and then again, all these curves go on forever and ever, so that's why it's kind of hard to see them. Or vice versa, right? If I have a cosine curve and I slide it over, now remember this curve went in both directions, right? Forever and ever and ever. So imagine I took this whole curve and slid it right. Well, this point that was over here is now going to move here, and then again, it's now going to look like a sine curve. So that's one of the issues with these graphs. And it's not a bad thing or a good thing. It's just what it is. So oftentimes, amplitude changes are easy to see. Period changes are fairly easy to see. Midline changes are really easy to see. But again, these left or right translations, these left or right slides, are actually kind of difficult to see. Now, we're not going to deal a ton with them, so don't overly stress about them. But you just have to understand that they are possible, right? So let me just do 2 kind of quick examples here. So here is a function. It's got an amplitude of 3. Inside the function, we have x plus pi over 3. And the midline is 4, right? So now if we want to talk about all the features, right? We see the amplitude is 3 right there. We see the midline is now y equals -4. The entire midline is down 4. The b value is a 1, so the period remains 2 pi. 2 pi divided by 1 is still 2 pi. But notice that this whole graph is going left pi over 3. So I'm literally taking the entire graph, which extends forever in both directions, and sliding it left pi over 3. So again, pretty easy to understand, but you just got to make sure you see it and understand this new type of transformation. All right, let's do one more here. 2 cosine of 2x minus 6 inside, and then a plus 5 on the outside. So we see that amplitude is 2. Midline is now y equals 5. My b value is 2, so my period is half now. My period is now only pi. But now there's also a shift. There's also a shift to the right. Looks like a minus sign. But we got to hold on a second. Remember, and we saw this way long ago in our transformation unit, that I know it looks like you want to say right 6. It looks like I want to say right 6 so bad. But you actually got to factor out that 2. Because that happens first. So we're going to inside factor out that 2, and we get x minus 3. So the real transformation is right 3. And if you recall, we had this same issue back in our transformation unit where you got to be careful when you're working on the inside. Sometimes you need to factor out that b value to really get a good look at what that c value is. So be careful with that, right? And again, we're not going to do an overwhelming large amount of stuff with this because, again, I don't like the fact that when you slide these left and right, they really kind of do look the same. But it is very easy to do, very easy to understand. So I hope you guys understand that. All right, so what we want to work on now is actually writing functions giving features. So like, you know, we've looked at several graphs. We've talked about amplitude, period, midline. Now what we want to do is say, okay, I don't want to look at a graph. I mean, I could, but I want to actually create the function based on the features. And this is actually so easy. I mean, it really is. Because, you know, the period is the a. Whoa, not period. I'm sorry. I said that wrong. The amplitude is the a value. The midline is that back d value. The only thing you got to be careful of is the period because it's not the b value. So the period equals 2 pi divided by b. So I'm given that the period is 6. So what I actually have to do here is I got to solve for that b value. So you're given the period, you're solving for the b value that actually goes into the function. So multiply that b value over, and then divide everything by 6. So b equals 2 pi over 6, which reduces to pi over 3. So now when I write my function here, I'm going to write y equals, this is a sine function, amplitude goes first, 4 sine, inside, and then I have a plus 7 on the outside, that's my midline. Now on the inside is b times x, that's going to be pi over 3 times x. So there it is, it's really that easy. So what I actually, again, would recommend doing is just kind of confirming, right? Amplitude is pretty easy to see, midline's pretty easy to see, but confirm that the b value does create a period of 6. So just very briefly, you know, go back to, you know, what we were doing in the previous part 3 is actually finding the period length. So we'd say 2 pi divided by pi over 3. That's the same thing as multiplying by the reciprocal. That'll cancel this out. Pi's cancel. 2 times 3 is 6. So we do confirm that this b value does produce a period of 6. All right, let's try another one here. All right, this time sine function. Period is 3 pi over 4. Amplitude, there's my A. That's easy. Midline, there's my D. That's easy. The only thing that's tricky is just, again, solving. So we know that the period length equals the formula 2 pi over B. So what we have to do now is solve for that B value. One easy way to do this here is to cross multiply. So we get 3 pi B equals 8 pi. Then I got to divide everything by 3 pi to get rid of this. And I get 8 thirds. 8 thirds. The pi's cancel. I just get 8 thirds. Interesting. Weird, but it is what it is. So y equals 2. There's my amplitude. Sine of 8 thirds x. And minus 8 there is my midline. So notice there was no translation left or right, so I don't have to worry about that. Again, that does make the problem a little bit trickier. But again, notice that 8 thirds there. And again, I really emphasize practicing going backwards to make sure that it works out. So 2 pi divided by 8 thirds, 2 pi divided by b equals my period, times by 3/8 in order to cancel it out. The 2 reduces that 8 to a 4, and we get a period of 3 pi over 4. Pretty easy, pretty simple. Hopefully you guys understand that. And these should be pretty easy problems to do. All right, now you must also identify, we also want to work the other way around, right? So here we want to give you a graph and you write the function. So it's literally just like the previous two problems we did. In the previous two problems we did, I gave you the key features, you made the function, and I hope you agree with me, that was pretty simple. Here, I'm going to give you the graph. So what you have to do first is look at that graph, identify the period, identify the amplitude, identify the midline, and then you're going to do literally what we just did in the previous problems. We're going to put them together to create the function. So here we go. Let's look at this function. And the first thing I think is the best thing to do is to identify the midline. So the midline is right in the middle. Max is 4, min is -4. That puts 0 right smack dab in the middle. So midline is y equals 0. From that midline, we clearly have an amplitude of up 4, down 4, so the amplitude is 4. That's pretty obvious to see. Now, notice that I'm starting above the midline. I'm starting above the midline. That's a sign that this is a cosine graph. And then we see that cosine graph go to the midline, down to the min, back to the midline, and then back. So there's one full period. Let me draw some lines here. There's one full period of cosine right here. And you say, well, what is that period length? Well, look, 4 pi. So there's the period of 4 pi. So once you've identified those things, now it's really easy. So the amplitude is your A value. The midline is your D value. Now the only thing I got to do real quick again is I got to solve for that B value. So again, period length 4 pi equals 2 pi divided by B. Multiply the B over, we get 4 pi times B equals 2 pi. Divide everything by 4 pi, and we get a B value of 1/2. Pi's canceled, 2 divided by 4 is 1/2. So this is y equals amplitude 4 cosine of 1/2 x, and then you don't really need to do this, but I'll put a +0 on the outside, that way it emphasizes it. And the cool thing is, I would recommend, a test or quiz, really using Desmos to graph this and confirm that it looks like this correctly. But I do want to say this one more time. I'm not trying to overcomplicate things. I just want to make a really good observation. I hope this problem made sense, but this actually could be a sine curve. Because imagine that I had a sine curve that started right here at its midline, went up to its max, down to its min, back to the midline. But this would be a sine curve that got translated left. So I could write this as a sine curve. It would still have a period of 4 pi. It would still have an amplitude of 4. It would still have a midline of 0. But there would need to be an extra translation left in there. And again, that's a little trickier to do. So I'm not saying you can't do it, but I just think it makes more sense to use this as a cosine curve. But the point I'm trying to make is that almost any of these graphs could be looked at as sine or cosine, all depending where you think about starting the graph. But I like to keep things as most basic as we can, and that's where I have the answer there in red. All right, let's look at another one here. Again, I think identifying the midline first is very helpful. So max is 1, min is -3. 1 and -3 is -2. Half -2 is -1. So again, we see that midline here at y equals -1. You can just find the middle of the min and max. So y equals -1. We clearly see the amplitude is 2. From that midline, we go up 2, we go down 2. So the amplitude is 2. So those are all very easy things. And then again, look at the midline here. I'm starting on the midline. Yeah, it got shifted down, but that's because of the midline change. And I'm starting on that midline. I'm going up to my max, down to my min, back to the midline. That is a sine curve. And one full period of that took 6 pi. And again, now I know my D value. I know my A value. All I got to do is find the B value. So 6 pi equals 2 pi divided by B. Multiply the B over. Divide everything by 6 pi. And the pi's canceled. 2 6 is 1/3. So there we go. So y equals my amplitude of 2 sine of 1/3 x and -1. But again, can't hurt emphasizing again is that I could look at this as a cosine curve. If I started it right here, and that would be a translation right. And then I went down to my min, back up to that starting point, there would be a cosine curve. So again, I could do this as a cosine curve. Midline doesn't change, amplitude doesn't change, period doesn't change, but there would be that extra translation as that C value. But that does confuse a lot of kids. That's why just do it this way and you avoid it completely. All right, let's do one more here. So again, midline I think is important to find first. So we have a 7 here is my max. We have a 3 here is my min. 7 and 3 is 10. Divided by 2 is 5. So that puts my midline right here at 5. Most kids just kind of eyeball that, but again, make sure you take the time to see that you're correct. So that's my midline is at y equals 5. So the whole thing went up 5. My amplitude is 2 because from that 5, I went up to 7, down to 3. And then again, I'm starting above, right? Where do you start? I'm starting above the midline, going down to my min, back up to that max. So that's a cosine curve. And how long did that take? There it is, 3 pi. So my period is 3 pi. All I have to do is correctly find the b value. So period 3 pi equals 2 pi divided by b. Multiply that over. I mean, how easy is this? Come on, so simple. 3 pi divided by, that cancels this out. Pi's cancel, and we get b equals 2/3. So now my function is y equals amplitude 2 cosine of 2/3 x. And then make sure that that plus 5 goes on the outside. So very, 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 very simple. Hope everybody agrees with me on that. All right, what I now want to do is, again, talk about these transformations, but I really want to focus on the points now, right? I think we understand the function. I think we understand the graph. I really want to focus on those 5 big points. So let's actually use this last example that we just looked at here to make this discussion. So that last example, y was 2 cosine of 2/3 x plus 5. And again, we already identified the amplitude was 2, and we can identify that now with the function. The midline is y equals 5, so the whole thing went up 5. And then again, we already know the period length, right? We already talked about the period length being 3 pi, but just so you can understand that, period length is 2 pi divided by the b value, which is 2/3. But instead of dividing by a fraction, I'm going to multiply by the reciprocal, which is 3/2. So that cancels out. 2's cancel, and we just get the 3 pi. Okay, so how does that affect the 5 points? And I want to actually show you this in the graph. So let's talk about the original 5 points. So the big 5, I call it the big 5 points. Now for cosine, the big 5 points for the parent function is at 0. It starts up at 1. And I'm just following around the unit circle. At pi over 2, it's back to the midline at 0. At pi, it dips all the way down to its lowest point, -1. At 3 pi over 2, it's back to the midline at 0. And in a full circle, it's back to where it began at 1. And again, all I'm doing is I'm following the x-coordinate, that's cosine, as I go around the unit circle. So at 0 radians, the x-coordinate's 1. At pi over 2, the x-coordinate's 0. At pi, the x-coordinate's -1. At 3 pi over 2, the x-coordinate is 0. And at 2 pi, it's back to 1. And that creates these points. Now let's show how these transformations affect these points. All right, so first off, amplitude and midline, those are things that affect only the y. So midline is first, amplitude is first. So the amplitude gets stretched, right? It stretches the max up to a 2, and the min down to a -2, and the max up to a 2 as well. Now the zeros obviously don't change because they're the midline. So again, that 2 is out front, right? You multiply by 2. So I'm taking my y values and I'm multiplying them by 2. Anything that happens outside the function affects y. Timesing by 2, if you're thinking about, well, what about the plus 5? Yeah, order of operations, multiplication comes first. So all my y's get multiplied by 2. 0 times 2 is 0. That's why they stay. But then everything goes up 5. So all of my y values go up 5. So that 2 goes up to a 7. That 0 goes up to a 5. The -2 goes up to a 3. The 0 goes up to a 5. And that 2 at the end goes up to a 7, which is, again, back to where I began. So there's my y coordinates, right? So the first thing that happened was they got multiplied by 2 for that amplitude change, and then everything just had 5 added to them. That's usually pretty easy. Most students don't mess those up. But now let's talk about the period change. And this is where we got to really kind of, hone in here and focus. So the period is typically 2 pi. So think about that, right? So we begin at 0, right, the very beginning, 0 rotations. Very, very beginning of the unit circle, 0. Then at a quarter rotation, we're at the very top of the unit circle, which is pi over 2. At a half a rotation, we're at pi. And then at 3/4 of a rotation, we're at 3 pi over 2. Get 3/4 of a circle. Just look at your unit circle. 3/4, 3 pi over 2. And then at 1 full rotation. So, we talked about using radians and how you go around the unit circle. I hope everybody understands 0, pi over 2, pi, 3 pi over 2, 2 pi. But if we're thinking about rotations, how much of a rotation? When we go around that unit circle, we're talking about a quarter. That's at the very top, 1/4. A half, that's a half a circle, half a rotation. 3/4, that's the bottom, 3/4 of the way around the circle. And then again, 1 full circle. And that's going to come in handy here in a second. Because now my period length is 3 pi. So what typically takes me 0 to 2 pi is now going to take me 0 to 3 pi. Hopefully that makes sense, right? That should make sense, right? So again, usually takes me 2 pi for this whole thing to happen, but now it's going to take 3 pi. So this middle point is half of that. So half of 3 pi is 3 pi over 2. It's pretty easy, right? That's just my halfway point. This is a quarter of the way through, right? So that'd be 3 pi over 4. And this is my 3/4 point. That would be 3/4. That would be 9 pi. And here, sometimes if you need to see it, 3/4 times 3 pi. That's going to be 9 pi over 4. 9/4 pi. And if you think about it, that actually makes sense even from the very beginning, right? Like we know 2 pi is a full circle. So half of that would be just pi. A quarter of that, 1/4 of 2 pi would be pi over 2. 3/4 of that would be 3 pi over 2. So if we just think about a full circle, a full cycle, a full period being 2 pi, then we can understand half of that is pi, a quarter of that, 3/4 of that. So that's exactly what I'm doing, right? It really should be that simple. I'm saying a full period is now 3 pi. You always start at 0. Half of that is 3 pi over 2. A quarter of that is 3 pi over 4. And 3/4 of that is 9 pi over 4. It's just really just multiplying. And then again, the cool thing is now we can actually go back to that graph. Check it out. Here was that first point at 0,7. That second point was at 3 pi over 4. That's going to happen right here, right between pi over 2 and pi is 3 pi over 4. So here's 3 pi over 4, comma 5. Here's the 3 pi over 2, comma 3 right here. 3 pi over 2, comma 3. And 9/4 pi, comma 5. That's this value right here. 9/4 pi, comma 5. That's back at the midline. And then a full circle is now 3 pi. And that puts us back up here at 7, at 3 pi. So again, we can actually track those big 5 points. And I think that that's pretty cool and really, really simple to do. All right, let's do one more of those types of problems just because I really want it to make sense. Let's do another one of the ones that we actually have the graph. That way we could go back and look at it. Y equals 2 sine of 1/3 x minus 1. All right, so just looking at this, in case you've forgotten, the amplitude is clearly 2. The midline is clearly y equals -1. And then again, let's find the period length real quick. It's 2 pi divided by 1/3, but instead of dividing, I'm going to multiply by 3 over 1. So it's now 6 pi. All right, so again, this is sine now. So let's remember the big 5 points for sine. Sine starts at 0, 0. So it's on that midline. At pi over 2, it reaches its max of 1. At pi, it's back to the midline. At 3 pi over 2, it reaches its min at -1. And at 2 pi, it's back to its midline. So again, let's handle the amplitude and the midline change first because these are actually the easiest to see. So the amplitude is out in front. That's going to multiply all the y's by 2. So 0 times 2 is still 0. 1 times 2 is 2. 0 stays at 0. -1 comes to -2. And then 0 stays 0. Again, I'm vertically stretching that, and that's why everything gets multiplied by 2. But then the entire graph goes down 1. If everything goes down 1, that affects all my y's. All my y's go down 1. So this point becomes a -1. This point becomes a 1. This next point becomes a -1. And then this next point becomes a -3. and then the last point becomes a negative 1. So literally 0 minus 1 is negative 1, 2 minus 1 is 1, 0 minus 1 is negative 1, negative 2 minus 1 is negative 3, and 0 minus 1 is negative 1. All right, now that I handled that, all I got to do is handle the period length, right? And this is, again, this should be easy. We start at 0, but now instead of ending at 2 pi, we end at 6 pi. And this point right here is my point that's in the middle. That's my half point. Half of 6 pi, 3 pi, easy. This is my quarter point right here. It's a quarter of the circle. So 1/4 of 6 pi will reduce to 3 pi over 2. So this is 3 pi over 2, or 1.5 if you prefer, but we like fractions better. And then again, this point right here is my 3/4 point. So 3/4 times 6 pi, that's going to be 18 pi over 4, but that of course reduces to 9/2 pi. How easy is that? Right, you're just thinking about that unit circle, right? And here is 1/4 of the unit circle. Here's 1/2 of the unit circle. Here's 3/4 of the unit circle, and here's 1 full unit circle. So that's all these points are: beginning, a quarter, a half, 3/4, and a full unit circle. So when your period changes, you just got to consider what those new points are going to become. And we could actually go back and look at the graph here. So we see this first point right here is at 0, negative 1. I'm going to go ahead and erase, whoa boy, sorry. I'm going to erase all this, that way we can look at it all really, really nicely. All right, here's that first point at 0, negative 1. Then we see that next point here at 3 pi over 2. We were at positive 1. 3 pi over 2, oh, wrong graph there, sorry. 3 pi over 2, we were at positive 1. I'm jumping all over the place here. 3 pi over 2, we were at positive 1. At 3 pi, we were back to that midline of negative 1. At 9 pi over 2, we reached that min of negative 3. And then at 6 pi, a full circle, we were back to that midline at negative 1. So there were those points there. And again, it's so easy to find these points. I mean, there really is. So be prepared to understand this. It's really, really simple to think about where are those 5 key points. So what have we learned, right? So I should be able to give you the features of the graph and you create the function. I should be able to give you a graph and you find the key features, then create the function. And then this last thing that we're doing here is really making the graph. So I give you the function, you identify the key points. From those key points, you create the new 5, right? We have the original 5, we create the new 5 points, and then we just make a graph of those new 5 points, and then we connect them, and we got this beautiful curve. So once you find these new 5 points, all you gotta do is go ahead and graph them like I just did here, and the green dots, and then connect the dots, and there is your beautiful sine curve. So it's really not that bad. It's just understanding how those points get translated or get transformed. And I don't think it's overly difficult. Amplitude and midline affect the y pretty easily, pretty common sense wise. And then the period is a little bit weird, but just remember, just think about those original 5. And they used to go to 2 pi, now it goes to 6 pi. And then I got to think about the half point, the quarter point, the 3/4 point, and all that goes together to find those new points. Grab those new points, you got yourself your graph. I mean, it really is that simple. All right, guys, that's it for graphing sine and cosine. I know it was 4 very long parts, but they all come together, and I hope it really makes a lot of sense. And there is a lot of detail, but at the same time, it's really just a couple big ideas that go into making these graphs. And once you get a good grip on those big ideas, it's quite simple. All right, see you in the next lesson.